tried yesterday's session. You practiced that matplotlib that we learned in the last session. We tried various graphs like um, line graph, bar graph, pie chart, right? So those things are handy when it comes to data visualization. Okay. In this session, we are going to learn a new module called Pandas, and this is used for data analysis. Okay, and this module is also part of data science, meaning when you have a huge chunk of data, and in the format like CSV, how we can extract that data from files and perform analysis, right? So there are various phases of that. I mean, you can use this module for analyzing data. That means you can view or go through all the content and analyze. In addition to that, you can also use this module for cleaning, because let's say you have a million record of some data point, and then there is a possibility that some of the cells or columns or somewhere in that data you have empty cells, or you have blank values, or you have null values. um, in addition, you might have some invalid data. Okay. So while analyzing data, let's say out of 1 million rows, if you have a bad record in, let's say, about 10 rows, um, it won't have a big impact if you just remove those 10 rows, right? Because still you have a huge chunk of data. So that kind of cleaning we can do easily using pandas. You can delete the rows where the cell is null, or you can delete the rows where it has blank values or invalid. You can just remove those rows so that you have valid information for analyzing, right? So that is about cleaning, and then you can explore also, meaning you can dig down to the huge this data, and you can always explore what fields you want to explore, or what columns you want to explore, and so on. So that's about exploring the data using pandas. Then you can also manipulate, meaning you can modify the data as well. For example, there is an age column, and then in age column, by mistake, you're getting values which is greater than, let's say, 120. Okay. So now you want to manipulate it, you want to change, right? If there is any value which is greater than 120 in the age column, you may want to replace that with some of the valid values, like you want to just replace it with null or zero or something of that sort. Okay, so that's about manipulating. And then there are some more calculations you can do, like you can find the average value of the column, you can find the maximum value, minimum value, right? These things you can analyze from the CSV file or comma separated file. Okay. So when we clean the data, it is mentioning here like examples could deleting rows that are not relevant. So if something is not relevant or having wrong values, you can just clean, you can just remove the rows. All right. Now, if you want this pandas in your computer to work, you will have to install it, right? To install the command is pip install pandas. All right. And that is, you can just go to command prompt, right? Just go to command prompt and just type pip install pandas. So if you give this command in command prompt, the pandas module should be installed in your computer. All right. So that's about the basics of what pandas is and what it can do, right? Let's move ahead and let's write a code to get more clarity on pandas. All right. First, we'll see something called series, right? Um, so this piece of code, if you see, we are going to import pandas as PD. So PD is the alias name for this module, and then we are creating a score, which is just a plain list. Okay, so this list is having three values, and that is if I simply print this, right? If I simply print the score, I'm getting just the list item, right? So all these list items got printed. Now, instead of printing, I'm creating a series. So PD has a method called series. Now, this core, which is a list, has become a series. Okay. Now, if I, excuse me, so if I just print series, right? So what will happen is I get a series like this 0, 1, 2. Okay, so 0 is 20, 1 is 27, 2 is 32. That means basically I've got a header for this. Right? So normally list will not have the keys, it will only have values, and that is why we use dictionary or objects and so on. So to make it more useful, what this series function will do is this will give us an additional, the header for these or the index for these basically. Okay. Now, if you want to make it more meaningful, that means if you want to instead of 0, 1, and 2, I want to give some different name, right? So for that, what we can do is instead of we give period series score, then we give index. So if you give index like this, so there are three values, right? 20, 27, 32. For these three values, I am giving index John, Kathy, and Ria. Okay. That means the first value belongs to John, second value is for Kathy, third value is for Ria. Okay. So now this will be more meaningful, right? This is more meaningful. That means what we are trying to show is we are trying to show the score of John is 20, the score of Kathy is 27, and score of Ria is 32. That is what we want to show. So if I run this, now you see it is coming like this, like John, Kathy, Ria, and their respective score. That is the use of this series function. Okay. Now, if I print series, the whole series will be printed. And if I try to print series of 0, now only the first value will be printed, which is 20. Okay. Series of 0 means this is the first value, right? So you can access this series by giving a series of 0. Okay. You can also access this by giving the index name. That means I can give series of John. I give series of John. Also, I am getting the value 20. Correct? So that is the advantage of having series. If you are not using series and if you're simply using score, then there is no way to assign this to a particular header. All we can do is print score of 0, score of 1, and score of 2, right? So in this case, we have assigned a header or a title or an index to these values to make it more meaningful. All right. So that is about series. Now let's go ahead and explore something called, you can create a series using dictionary also, right? That means, so in this example, um, right? In this example, what we did was we created a series through a list, right? We did it using a list. Now, what if we have a dictionary? That means, let's say this example. In this example, marks is a dictionary, right? So here uh, we have a keys called Suman, Nikhil, and Nikki, and then the keys are this, and the value for Suman is 20 and 27 and 32 respectively, right? So here that confusion of index does not come, correct? If I simply give my series equals pd dot series of marks, it will automatically take those in this fashion. So if I try to print it, see, it is now printing in this order. See, Suman, Nikhil, and Nikki, it has taken as a series and it has also taken value. That means we don't have to use any index over here. Got the point? That means if, let's say, instead of dictionary, if I had list, if I had 20, comma, 27, 32, right? So instead of marks as dictionary, if I'm passing as a list, then making as a series, instead of showing Suman, Nikhil, and Nikki, it will show 0, 1, 2, right? 0, 1, 2 it is showing because this is a list. It does not have a key, right? So instead of this list, if I create a series from a dictionary, then it will automatically take these keys as the index. All right. Okay. So that's how we convert or create a series from a dictionary. Now let's say I want to create a series of only Suman and Nikhil, only first two indexes I want. I don't want the last one, right? If you simply convert, everything will come, right? So if you don't want everything, okay, what we can do is we can just give as an index over here. I can just give here comma index equals, in a list I can mention Suman, comma Niki. Now what will happen? It will create a series of only these two items. See, it has automatically taken Suman and Nikki as well as the values too. Got it? So that it has the capability to access these two as the keys, right? And then pull the values and store into the uh, series called my series. Now, if I'm printing my series, is printing 20 and 32, and you see it is also taking the data type as int 64. So it is by default taking integer 64 for the data type, so 64-bit integer. Okay, so that is how we convert from dictionary. So two things we have seen so far: to convert or to make a series out of a list, and to make a series out of a dictionary. All right. Now, second thing that we are going to learn is something called data frame. All right. Now, data frame is series is one dimensional, right? That means we had an index and then we were printing like this index was there and the value was there. What if we have two dimensional? That means, let's say if I open an Excel file, so if I have here, let's say name and uh, marks, right? Let's have name and marks. And I have John and then some marks, right? And then here in this example, this is actually not a series. Right? What was series we have seen just now? The series was something like this. Right? John 30. So like this we were getting the marks and all that. There was no header, nothing like that. So we were just having, this is called series. This is series. Now, same data, right? If I want to present like this in rows and column format, if I want to put it like this, name and marks. Now it has become two-dimensional, right? That means it has two fields, name and marks, and then it has respective values. Okay, now this is one way of doing it. Second way of doing it like this. I can have John, Leah, Kathy, and then I can have name marks over here. Right? Like this, I can show the marks. And there are two ways of analyzing or displaying the data. So let's say I have this, again I've imported pandas and then I'm creating a marks dictionary. So here if you see in this dictionary there are three keys, but the value has been given in a list. Okay, values inside a list. Now, if I try to, and then I'm just printing the series. What happens is this particular marks, which is a dictionary, that I am converting as a data frame, right? So before we have seen the method called series, now we are looking at a different method called data frame. So pd.dataframe of marks means the marks dictionary will become a data frame now. Okay, so data frame will look different. Now, if I try to print this, okay, if I try to print, so it is printing in this order. So the Suman, Nikhil, and Nikki has become the header, and these values are the value for this, and then we have an index. Okay, so by default, index is 0. Got my point? So it has printed like this, and then here as an index, I'm giving 0. Now, if I want to have more values, how it will become is it will become like 1, index will be 1, and this could be something else. It could be something else here, like this. This is a data frame. Okay, this is called a data frame. Now, because in here in this example, let me clear this. Because in this example, we had only one value in this list. That is why it is showing like this. Only zero, only one row is there. All right. Now let's say if I give more values, I give 20, comma 45, and here I give 27, comma 67, 32, comma 98. So if I give two values inside this list and then play, now what I'm getting, see I'm getting 0 and 1, right? It is showing in this order. Got it? So uh, now now instead of 0 and 1, now 0 and 1 is not making any sense, right? We don't know what is this 0 row and what is 1 row. We don't know that, correct? So what we can do is, like series, we can give index to this. Okay, that means when we create the data frame, when we create the data frame, I can give here comma marks, comma, then give index equals in a list, and let's say give here some headings, for example, I can give here maths. And I can give here science. Now what will happen? The index will be maths and science. So these values, whatever we are showing, now will make more sense to us. Correct? So now if I run this program, it will make more sense. Now we know this 20 is the marks of Suman and which belongs to maths, right? So he scored 20 in maths and 45 in science. Same thing goes with Nikhil and Nikki. So they have scored this marks in respective subjects. All right. So that means this particular data is something like this, right? It is showing here. Uh, I've given maths. Okay. Then I've given here science. So this is the output. I wanted it like this, and that is how I have displayed. Okay. Now, can you let's say, what if I want uh, like this? Okay, I want it like this. Maths, science. I want here John. Okay. Now, in this order, if I want some score, I want the data frame to be like this. Okay. So if you want in this order, we have to just make some minor changes to this, right? So when we create this dictionary, that means we want header to be, let's say, maths. This should be science. Let's say this should be English, for example. Now these will become the now and in this index, okay, I can give John, Kathy, and I can give yeah. Now what will happen if I run this? The headers will be like these, right? Headers. Something went wrong. What was that? Oh, sorry, I gave extra here. So now now what will happen is if I run this, now I'm getting like this. See, headers have become math, science, and English, and then name has become John and Kathy. So whichever way you want, you can display the content in a data frame accordingly. Correct? So that's pretty much on on how to create a data frame from a dictionary. So you have to give list here. That means um, because it is a multiple values, right? You have to give list in this place. Um, okay, and so we have given one value here. Okay, and then in this index I've given John. So now it is showing the marks of John in this order. Right. Now let's move forward. Um, Here, see, this is again creating with the dictionary. Let this example will give you more clarity now. Here, if you see, Now this DS, okay, is a data set. Here we have a dictionary name and age, right? And then name and age has a list, all right? And then we are converting this into a data frame and we are trying to print it. The similar example that we have just seen, but it might give you more clarity. So again, name and age are the column. Okay, name and age are the column here. And then we have the rows or the index as 0, 1, 2, right? And if you want to give the column names for that, you can just give the same thing over here, index equals in the list. You can give something like rank 1. Here it is below, so rank 2. So let's say, so if I give this heading over here, this will automatically take their um, rank 3. So I'm giving an index, so now it will come properly as rank 1, rank 2, rank 3, name and age. Okay, the first rank is Ria and age. So if you see here, in this case, if you observe, we are giving the first value, right? First value Ria is assigned to 23, correct? So the headers are name and age, which we have given, and these names, whatever we have mentioned, okay, this is a list inside a dictionary. Got it? And that's what we are displaying over here. Okay. Now, what we are going to see in this example is, now this data frame that we created. What we want is, we want to put this data into a CSV file. Got it? That means I want to create a file out of it. I want to create a file like this. All right. So let's see how we can do that. So you see this next line, d dot to underscore CSV. So this line, what it will do is, it will whatever D is, what is D? D is a data frame, okay, which has this information. What you see below in the screen. Now this information should go and store in a new file called test.csv. All right, and I'm giving index equals false. I'll just tell you why I've done that. So let me run this program. All right. So in this example, what it is doing is, it is creating a data frame from this particular, dictionary, and then it is trying to create a new file called test.csv. Okay, and it will put this content into that file. So if I run this, um, you should see here a file called test.csv. I click, I see here. So now in this case, see name and age and this comma separated file got created. That means if I go to the folder where we have, you know, this particular project, and I should see a file called test.csv in this place. So test.csv is there. If I click and open it, double click and open it, will open in Excel, and this is what we had just created. Okay, so this is a comma separated file which we created, and it looks in Excel something like this. Okay, so this was possible because we had used to underscore CSV function, that comes with PD or Pandas module. Now we give index equals false, right? So if I'm not giving index equals false, what it will do is, it will, give an additional, hang on a second. Okay, so now if I run this, what it will do is, it will create, where is that? So it has created an, where is that? I run that and let me open this file. Okay, because it has index already. So if I give index equals false, what happens is the first row also will be taken as, let me open. That means the first row has been taken as, not an index, right? It is taken just as the value. And if I don't give it, okay, if I simply convert this into, wait, let's say I have not given something like this, simply I'm giving uh, data frame of ds, and then I try to run this. Okay, if I try to run this, now what has happened is it has created it like this. Okay, 0 1 2 name and a 0 1 2 and all that. So here if I give index equals false and then run this program, and then if you try to open, now see it is not showing that index 0 1 2 is not coming, right? 0 1 2 is not coming because we have given index equals false. So while creating a CSV file, it will not automatically assign 0 1 2 there. All right. So okay. So that is how we create a CSV file with this pandas module, right? So first we create a data frame here, and then so that data frame we are converting into a CSV. All right. Now in this data frame, we have another option. If you want to, let's say, print something. Let's say I want, if I simply give print D, the data frame, I give print D, it is printing everything, right? Okay, let's say I have here the index also. Index equals, and I'm giving here rank 1, rank 2, and rank 3, right? So now if I run this, it's showing it like this, right? Rank 1 2 3, name and age. Now if I want to locate, I want to know the value of this rank 1, what I can do is instead of giving the print D, I can simply give print D dot location rank 1. So if I give rank 1 location, now what is happening is it is showing the name and age of rank 1. See, Ria and 23 is coming of rank 1. Got it? So that is how we can take the no, make use of dot loc, which is dot location, right? So if I simply print D, that means everything is coming. And if you want to retrieve a particular index, give rank 1. When I give rank 1, these two values are there, right? Name and age. Both those, no, both the values will get printed. All right. Let's move forward. Now, next we'll see, how we can, uh, read from a file. Okay, so how we can read from data frame, files to data frame. That means, let's say I have a file over here, student.csv. Okay, so in this student.csv, I have name, age, score, and date of join, and all these four values I am getting. Correct? Name is there, age is there, score is there, and then date of join. Now I want to read this CSV file. Okay, that means CSV file is this one, right? What is the name of this file? Student, sorry. Okay, so I have student. So this is the CSV file. Okay, and this is the file. I have four columns and these four rows, right? Now, this I want to read. Okay, basically, I want to read that particular CSV file. I mean, we might have gotten this file from some other application or somewhere else for data analysis. So, we are trying to access this file using a Python program and then we will analyze. Okay, so first for that we have to read that first, right? We need to read it. So for that, what we will do, we will create an object here. So same we are calling pandas module. Now in this function that we are going to use is read underscore CSV. To create a new file, what did we use? We used to underscore CSV, right? So read underscore CSV will read this particular file and then put the content in a variable D. Okay. Now, if I simply print D, so what will happen? It will print the content of student.csv, right? If you simply read and print, so you see it has automatically taken, okay, all these values and it is printing. Now there are some more options. So let's say, so we were trying to read student.csv, right? So, so another thing is if I, so let's say, so in this student.csv, we have what all columns: name, age, score, date of join, everything is there, right? So we don't want all the columns, we only want name column. So for that, there are some parameters, right? So I've given here read CSV, student.csv, and rows 3 means 3 rows only. See, only 3 rows came. Now, if I give only 2 and rows equals 2, so now only 2 rows are coming, Ria and Kathy. And then columns I have given only name. That is why only name column is appearing over here. All right. So these are some parameters that we can give along with this read underscore CSV function. Okay. Now, similarly, I can give here header equals none. If I give header equals none, it should basically show no header. That means it has taken this first row as the content. It has not taken the first row as the header. Okay. Because sometimes when we get this file from other sources, there may not be any header. Okay. So in that situation, we have to give header equals none. Otherwise, what will happen? The first row will become the header, right? That means, let me tell you one example. Let's say this row was not there, for example. If this row was not there, and if I simply give, if I don't give this header, now what will happen is the first row has become a header, you see, which is wrong. Okay, this is not an header. This is also a content. Now, because the file that we receive in this fashion, we have to consider the first row also as a data value. So in that case, we give header equals none. Now what will happen is it will assign 0, 1 2 3 as a header. See, 0, 1 2 3 has become header and 0, 1 2 3 has become the index, and this Ria Kathy, all this has become the data point. That is a use of header equals none. Okay. Now next is, what if I want uh, so this age is there, right? So if I want this age in float, now this age column is coming as a float, as a decimal point, correct? That is coming because I have given data type of age is float. Okay, if I give int, okay, now it will appear as an integer. See, age is coming as an integer. Okay, so that is the advantage of converting into JSON. Now let's analyze it. Let's do some analysis in this particular program. So I have a file called student.csv, right? Now I want to just print df.head. Okay, so it is going to print the uh, these particular rows. Okay, now if I give df.head of, let's say, 2, okay, now I'm getting only 2 rows. Got it? Only 2 rows. If I want to see only 2 rows of this particular file, I can just give head of 2. That means the first 2 rows will appear. Okay, that's what dot head is. Df dot head. Now, if I give, you know, by default, like if I'm not giving anything, right? If I'm not giving anything, simply I'm giving head, df dot head. So what happens is, initial characters will be initial rows, 5 rows will be getting displayed by default. Now if I give a particular number, then only that many rows will be displayed from top, from head. Similarly, if I give tail, right, so data frame, so we are going to read the student.csv and then giving df.tail of, let's say, 2. So what will happen, the last 2 row will be printed. See, John and Kathy, the last 2 rows got printed. Ria record did not come because we gave tail of 2, right? That is the use of the tail function. Now there's something called df.info. So if I give df.info, it is going to show some information about this CSV file. What it is telling us, it has, you see here, more analysis. It's what it's telling, there are 4 columns. Okay, in this file there are 4 columns. Okay, we got 4 columns, and then it is saying the first column, which is name. Okay, it is a not null. Not null means it has value. All the 4 cells has value. Okay, then it is an object. It is an object because it has a name, right? Ria is a name. Second is age column. Age column is telling not null, that means it has a value, and then it is an integer type. Score is also integer type. Dog is like, a integer, then it is an object. So like this, it is giving the information, and then it is telling data types, objects, and total memory, how much memory it has taken of this file. That is about the info. Okay, if you give the info function, that is what it does. So we have seen head function, tail function, and info function. Let's perform some cleaning activity. Okay, so let's say I have here, uh, this is the cell, right? Now let me remove this age, or for this For this RIA row, I am removing the age. Okay, I'm making it null. That means that means if I simply print df, okay, I'm printing df, so it is showing, you see here, rows and columns. This score field is null, right? Null for the first row. So, like I said earlier, there could be like thousands and millions of records, and if we want to clean or remove all the rows where any field is null, okay, then what we can do is we can use a function called drop na. See here, if I give drop na, it will remove the empty cell. Df dot drop na will remove the empty cell, and then it is going to show the other values. Now you see the first RIA record is not coming. Okay, it's not coming because we have removed it, and we have removed because the one value was null in that. So if I again give the value here, okay, and then if I run this program, now the RIA record should come. See, RIA record is coming. So that is a use of drop na function. All right. Uh, Moving ahead. So there are some more cleaning activities we can perform in this. So we have seen this drop NA already, right? Remove. Now sometimes there could be a null value instead of this, instead of blank, it can have null value, right? So if you don't want this null value, okay, and if you run the program, see the null value, that row has been removed. That is what is a drop NA. In place equal true means if there is any null value, then it will replace. Okay, empty and null, there are difference. See, actually there is something here, but it is null. That is why it has removed it. Okay. And then let's say if I want to replace the null value. Okay, for that we use a function called fill NA. So there is a null value for RIA account, RIA row, and I want to replace that null with 130. Okay, so if I run this, now you see the RIA value has been changed, the score has been changed to 130. Okay, actually it is null. So actually it is null, but we replace it with 130. Okay, that is a use of fill NA function. Uh, you can also fill a particular field, because fill NA function will replace wherever there is a null. For example, I have a null in here, and then I have a null, let's say here in age. There are two null values. Okay, so this fill NA will fill wherever there is a null. See, 130 has been filled here, 130 has filled here also. Both the places 130 has been filled. We don't want that, suppose. We want only to fill in the score. If score field is null, then we have to put 130. Now, if I run this, you see this age column, it is still null, but in the score column, the null has been replaced with 130, right? That is how we can replace it. Similarly, we can replace with mean median mode. So now score field, if it is null, so in this case, score is null, right? For this RIA. Okay. Well, okay. So now I have changed the value, and if you see, so now it has filled this with 12. Okay, 12 it has taken as the mode of 0. Okay, because the most common, actually there is nothing most common over here, so it has taken 12. Let's say I give here mean. So now the first value, that means the RIA's score, will change as the average of it. So it has changed as 41.33, right? So it has changed it to mean. So that is how we can make it mean median mode for, and we can fill the value accordingly. Actually the value is not there. See, in that file there is no value. Okay, we are analyzing, right? We're analyzing the data by giving some formula here. Okay, so that's pretty much on that cleaning. Okay, now we can also have some fields like we can convert the date. Now, for example, uh, and this date fields will not be in a proper format. For example, here if you see in this particular CSV file, see here there's a date of join, right? So in this case it is 1/1/2023, and the second row it is 2023/12/1. Both are different formats. Okay, format is different. So what it will do, it will automatically convert that into date and time. See, we are using pd dot to underscore date time. So what it will do, it will read the student.csv file, and then it will replace the date of join column. Okay, all the date of join column will be replaced with the date and time format. Got it? And that is why we are getting this in a date format. See, actually the content is how I've given single quote. See, it is not date format, it is a string format. See, it is also a string format. And then the order is also different. In this it is, ddmmyy, and here it is yymmdd, right? So when I give this to date time, it will convert that into a proper date, and see below I'm getting here in a proper date format. That is the use of to underscore date time function. Okay. Uh, Now something called removing. So if you want to remove the unnecessary data, okay, that means here if you see in this first index, right? First index, I'm giving age as 178. Sorry, let's say I'm giving here 126 or 176. So this is not a correct information, right? I mean, if I simply print it, it is showing age as 176. Okay, which is wrong data. Okay, it's wrong data. So what we can do, we can correct it. How we can correct it? We can give location of that, that location of that particular index. Age will convert into 26. Okay. Now what will happen is the see. Wait. Now you see the Ria's age has been changed from 176 to 167 to 26. So like that we can change it. That is what we use location. So df dot location 0 means in the zeroth index, age column will be 26. See like this. Okay. Now similarly we can run a loop also. That means I can run a loop. I can read all the data, read all the data and see if location of age is greater than 120, it will replace with 0. Wherever it is greater than 120, it will replace with 0. So now if you see it has become 0. So this simple Python loop I have given for r in df.index. Df.index means it will read all the indexes, and one by one it will check if age column is greater than 120. If it is greater, then it will replace our no that index of age to 0. Okay, this is if you want to replace it. If you want to remove that column, let's say if the age value is greater than 120, if you want to remove, just give drop. So drop means remove that particular field. So the rear row itself is not there. It is not there because the age field was greater than 120. Right? In place equals 2 we are giving because we wanted to replace it with the, we want to remove the row if if r was invalid, right? That is what the use of, that is how we replace a content. Now similarly we can remove the duplicate also. That means here you see I have a duplicate. Let's say I give a duplicate value, Kathy, I repeat twice. This is coming at twice. Exact same thing, right? Everything is same. The name, age, code. So by mistake, sometimes when you get the data, it will have duplicate values. So if you have duplicates value and if you don't want that extra value, what we can do is we can use the function duplicated. See, duplicated. So if I just simply give, see, I am reading that CSV file, student.csv, and then giving df dot duplicated. So now what will happen is it will show that third row is duplicated, which is true. The first, second, third was fine. The fourth row is a duplicate, so it is returning true. Okay. Now, if you want to remove the duplicate rows, then just give drop underscore duplicates in place equals true. So if I give drop duplicates, wherever there is a duplicate record, that will be dropped or removed. And then if I print duplicated, everything will be correct. See, all coming false, false, false. Because there is no duplicate record now. All right. So that's about duplicated function. So all right. So with this, we have seen pretty much most of these functions of pandas, right? And hope you have understood this.